Hello friends, welcome back. Hearty welcome to you. As part of NCERT 9th grade polynomials, let us try to understand the concept of factor theorem and try to solve some examples related to that. Now what's the meaning of a factor? To understand that, let us take two simple numbers. Let us say, suppose I want to divide 17 with 6. Now, how can I tell whether 6 is a factor of 17 or not? Let us divide with this 6. 6 2s are 12. Then the remainder comes as 5. We know that if 6 is a factor of 17, then the remainder should be 0, not other number. Let us take now 18 and try to divide with 6. 6 3s are 18 and the remainder is 0. So we know that now 6 is a factor of 18 because the remainder is 0. So the point we have to understand is factor means remainder is equals to 0. Or can I say remainder equals to 0 or remainder is 0, that means it is a factor. So this is the logic. Can we apply the same logic to polynomials? Let's go ahead and see what we understood from the last class. We said that if p of x is divided by a linear polynomial x minus a, then the remainder is p of a. Now how we can extend the remainder theorem to factor theorem? But we know that x minus a is a factor of p of x only if and only if remainder is equals to 0. That means p of a equals to 0. So can we now state factor theorem saying that if p of x is a polynomial of degree more than or equal to 1 and it is divided by a linear polynomial x minus a, then x minus a is a factor if p of a equals to 0, or p of a equals to 0 if x minus a is a factor. Because we know that remainder is 0 when x minus a is a factor. X minus a is a factor, then obviously remainder should be equals to 0. So let us state the theorem now. If p of x is divided by a linear polynomial x minus a, then according to factor theorem x minus a is a factor. We know this happens only if the remainder is 0, if p of a equals to 0. So that can be one way we can say that. Another way we can say that p of a equals to 0 or remainder is 0 if x minus a is a factor. Let's read this again. If p of x is divided by a linear polynomial x minus a, then x minus a is a factor if p of a equals to 0. P of a equals to 0 if x minus a is a factor. Now let's look at this example. We have been given a polynomial. We have been asked to check whether x plus 1 is a factor of the polynomial or not. What we have to do? Very simple. We'll go to x plus 1, equate it to 0, find out the x value, that is minus 1. Now we will come back here and do p of minus 1. This is p of x. And we will check whether the value is equals to 0. Why we are checking for 0? Because if the remainder is 0, then only it is a factor. X plus 1 is a factor only if p of minus 1 equals to 0. So let's go ahead and substitute. We will have minus 1 whole to the power of 4, that is 1, plus 3 into minus 1 whole cube, that is minus 3, plus 3 into minus 1 whole square, that is plus 3, plus minus 1 plus 1. Let us simplify that. We will have 1 minus 1 minus 3 plus 3, left out is 1. But what we need to have to say that x plus 1 is a factor of the polynomial, we should have p minus 1 equals to 0. But we are not getting 0. That means We know very clearly that x plus 1 is not a factor of x to the power of 4 plus 3x cube plus 3x square plus x plus 1. So we can write down equals to 1, which is not equals to 0, therefore not a factor. Let's try another polynomial. We will take p of x is equal to x cube minus 4x square plus x plus 6 and g of x equals to x minus 3. Now what we have to do? First we have to equate the linear polynomials to 0. X minus 3 is 0, x equals to 3. Now let's come back and do what is p of 3. If p of 3 is 0, then we know x minus 3 is a factor of given p of x. What is p of 3? 3 cube minus 4 into 3 square plus 3 plus 6. Let us simplify that. We will have 27 minus 36 plus 3 plus 6. That is equals to 36 minus 36 equals to 0. So x minus 3 is a factor of given polynomial. Let's try some more problems. Other type of problems are where they will give us the polynomials, like we have been given, let us say p of x equals to kx square minus 3x plus k, and we have been told that x minus 1 is a factor of this polynomial. We have to find out the value of k. Now what we have to do again? Find out the 0 of the linear polynomial. X minus 1 is 0, x equals to 1. If p of 1 equals to 0, then only it is a factor, and we have been told that x minus 1 is a factor of the given polynomial. X minus 1 is a factor of this. So we'll do p of 1 equals to 0. We will have k into 1 square minus 3 into 1 plus k is equal to 0. That gives us 2k minus 3 equals to 0, or k equals to 3 by 2. So we can be asked problems like this, where they will give us polynomial with a unknown constant, and we have to find out the value of the constant. Let's try some more problems. Now let us say we have been asked to factorize x square minus 7x plus 12. We can do this in two ways. One, we know already splitting the middle terms. The other way is using the factor theorem. So first let us do with splitting the middle terms. X square minus 7x plus 12. We know here sum equals to minus 7 and the product is equal to 12. We know product is positive, that means sum, and sum is negative, so both of them are negative. So 12 can be divided into 4 and 3, minus 4 minus 3. So can I write down x square minus 4x minus 3x plus 12? We can take x common, x into x minus 4 minus 3 into x minus 4, which is equals to x minus 3 into x minus 4. Now this is how we can do using splitting the middle terms. How we can solve this using the factor theorem? To solve by factor theorem, first let's go to the constant term x square minus 7x plus 12. Remember that coefficient of x square is 1. So in this case it's very easy. We can go to the constant term and check all the factors of the constant term. Now 12, what are the factors we have? Let us check. 12 factors are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. Now out of these numbers, two numbers are the zeros of this particular polynomial. Once we know the zeros as a and b, let us say, then we know x minus a into x minus b is our solution. So for that what we will do, we'll check one by one. Let us check for p of 1. P of 1 equals to 1 minus 7 plus 12, that is equals to 6, not equals to 0, so won't work out. Let us try for p of 3, that is 3 square minus 7 into 3 plus 12, that is 9 plus 12, 21 minus 21, 0. So P of 3 is a 0. Now let's try for P of 4. P of 4 is 4 square minus 7 into 4 plus 12, which is again 16 plus 12, 28 minus 28, 0. Now once we got that P of 3 and P of 4 are equals to 0, what's the meaning of that? If P of 3 equals to 0, that means x minus 3 is a factor. Similarly, P of 4 equals to 0, that means x minus 4 is a factor. So if we have been asked to solve this problem by factor theorem, you have to check whether the quotient of x square term is equal to 1 or not. If it is equals to 1, then you can directly go to the constant term, find out all the factors, try to substitute those values and check whether you are getting remainder equals to 0 or P of that value equals to 0. If P of 3 equals to 0, then x minus 3 is a factor. If P of 4 equals to 0, then x minus 4 is a factor. Let us try now one problem where the quotient of x square is not equals to 1. So let us say we have been asked to factorize 2x square plus 7x plus 3. Now observe that the quotient of x square is not equals to 1. In this case, we have to take factors of a rational number out of which in which the numerator is the constant term and the denominator is the quotient of x square. That is factors of 3 by 2, numerator by denominator, and 3 by 2, what are the factors? So let's write down for 3. First the factors are plus or minus 1, plus or minus 3, and the denominator we can have plus or minus 1 and plus or minus 2. Now we have to look for all the combinations where we have both numerator and denominator. So the factors can be plus or minus 1, plus or minus 3, plus or minus 1 by 2, plus or minus 3 by 2. I'll repeat again what we have to do. Look at the constant term and look at the quotient of x square. If quotient of x square is not equals to 1, then we have to do factors for not the constant term but constant term divided by quotient of x square term. In this case it is 3 by 2. Now what are the factors of 3 plus or minus 1 plus or minus 3? What are the factors of 2 plus or minus 1 plus or minus 2? Now we have to check all the combinations, different combinations. Plus or minus 1 we have taken, then plus or minus 1 by 2 we have done that, plus or minus 3 we have done that, then plus or minus 3 by 2. So we have taken all the combinations now. Out of this we have 1, 2, 3, 4 2s are 8 values. So we have to check these 8 values and we have to find out for which the P of x will be equals to 0. So let's go ahead and do that. First we'll try with P of 1, that is equals to 2 into 1 square plus 7 into 1 plus 3, that is 2 plus 7 plus 3, which is equals to 12, and that not equals to 0. So P of 1 is not a 0, so x minus 1 is not a factor. Now let us try with P of minus 3, because we have here minus 3. 2 into minus 3 whole square plus 7 into minus 3 plus 3. Simplify this. 2 into 9, 18 minus 21 plus 3 equals to 0. That means x plus 3 is a factor, so I can go ahead and write down one factor is x plus 3. Now what will be the other factor? To know that we have to go back and check the remaining ones. Let us check for P of 1 by 2, you can check minus 1 by 2. Let us check for minus 1 by 2. So that will be 2 into minus 1 by 2 whole square plus 7 into minus 1 by 2 plus 3. Let us simplify this. 2 into 1 by 4, that is 1 by 2 minus 7 by 2 plus 3. Simplify that, that is equals to 0. So we have p of minus 1 by 2 equals to 0. So can I write down x plus 1 by 2 is a factor. Now if you remember, what we did is we took 3 by 2 factors. Why we did that? Actually we took 2 out and we have written this as x square plus 7x by 2 plus 3 by 2. That is why we took the factors of 3 by 2. Now what we got now is 2 out, we have x plus 3 and then we have x plus 1 by 2. Take LCM, you will have 2x plus 1 by 2. 2 will cancel, you get 2x plus 1 into x plus 3. Now let's try one more type of problem when the degree is more than 2, like a cubic polynomial or fourth degree polynomial. With that we'll stop this session. Whenever we have been given a cubic polynomial and asked to factorize it, what we do generally is we'll try to use factor theorem method and try to find out one factor by substituting, taking the factors of the constant term. Here the constant term is 5. So the factors we have to consider are from 5. They are plus or minus 1 and plus or minus 5. So we'll check for p of 1, p of minus 1, p of 5, p of minus 5. One of them is equals to 0. So whenever the problems are of degree 3 or more than 3, what we will do is we'll find out one factor or two factors, then we'll try to divide the polynomial, given polynomial, with these factors or the product of these two factors whatever we got. Now in this case it is degree 3. So what we will do, we'll try to find out one factor, then we will divide with that factor and try to get the product of remaining two factors. Now let me show you how to do that. So let us check for p of 1. P of 1 equals to 1 minus 3 minus 9 minus 5, which is equals to minus 16, and that is not equals to 0. So it won't help us. Let us try with p of minus 1 now. That is minus 1 minus 3 then plus 9 and minus 5, and this time we seems to be lucky. We got equals to 0. So 9 minus 9 is 0. That means we know x plus 1 is a factor. This tells us that x plus 1 is a factor. Once we know x plus 1 is a factor, what we will do is we'll go to long division. We will divide the given polynomial with x plus 1. Now let's do with long division. We have x square, then we have x cube plus x square, then we'll subtract, we will have minus 4x square minus 9x. So we'll have minus 4x square minus 4x. Let us subtract again. We will have minus 5x minus 5. Next time with minus 5 we will have minus 5x minus 5. Let us subtract, we'll get everything 0. So we got x square minus 4x minus 5. Now we will use splitting the middle terms and try to find out the factors of x square minus 4x minus 5. That we know is x minus 5 into x plus 1. So now we got all the three factors. One factor is x plus 1. Remaining two factors are x minus 5 and x plus 1. So remember this concept. These are the type of problems asked in exams. Whenever we have been asked to factorize a polynomial of degree 3 or more than that, first find out one linear polynomial by using trial and error method. By using factor theorem, go to the constant term and see whether the quotient of x cube or x power 4 is equal to 1. In that case, go to the constant term as we did earlier, find out the factors and get one linear factor, that is like x plus 1 here. Now divide with that the given polynomial and try to get the product of the remaining two factors. Then you can use splitting the middle terms and you can easily find out the remaining factors. So this is briefly about the factor theorem concept and some of the examples or exercise problems, so that you can go ahead and try to finish exercise 2.4. So I'll catch you in the next session. Thanks for your time and support. Bye for now.